Greeting, my statistics friends. This is Chapter 8 from MA 215 Statistics, and we're going to take a look at problem number 8 from the homework set. Problem number 8 corresponds to our book 8.2, problem number 20 from our book. So this says a national newspaper reported that the state with the longest mean lifespan is Hawaii, where the population mean lifespan is 74 years. A random sample of 20 obituary notices in Honolulu gave the following information about lifespan in years of Honolulu residents. And we see the data listed here. So part I says use a calculator with the sample mean and standard deviation keys to find X bar and S. Then part 2I says, assuming the lifespan in Honolulu is approximately normally distributed, does this information indicate that the population mean lifespan for Honolulu residents is less than 74 years? And then it says use a 10% significance level. And then we've got a part A and a part B. And what is the sample statistic in part B? Part C says find the p-value. And then we're going to select the correct graphical representation. And then part D and E is our conclusions. Okay, so let's start this problem out from the beginning with part I, and I'm going to use my calculator. So in my TI-84, I went to the Stats menu and then Edit, and I put those pieces of data from the obituaries and the age at death for each of those values. Then I went back to the home screen and I went to the statistics menu and over to test, and I want a t-test. So why do I want a t-test? Well, I want a t-test because we're told that it's approximately normal distributed, so the data is roughly mound-shaped, right? Approximately distributed, that's the first thing we need. It was randomly information was collected, so a random sample, it says, of 20 obituaries, and we have no reason to believe that these data points are dependent on each other, so they're independent. So we have a random sample, we have roughly mound-shaped because it says normal distributed, and we have independent samples. So that's why we're going to use the student's T. Another thing to remember is we are not told the standard deviation of the entire population of Honolulu. So that's another clue that we're going to use the student's T. So I use the student's T, or the t-test, and we were given the data, and I put the data in list 1. So then I'm going to go down to the mu naught, and the mu naught is 74. So I got that from where the population mean lifespan is 74. So the thing I'm going to compare to in my test is this proposed age of 74 because of the population mean lifespan proposed is 74. So that's my mean naught. I put my information in list 1. I use a frequency 1 because I want to use 100% of each of the data points. So then I have not equal to, left tail, and right tail. So which of these two do I use? Well, looking at my information, it says lifespan for Honolulu residents is less than 74. So less than 74. So if you think about it, this is your mu that you're testing. The mu that you're testing is less than, and then 74 is this value up here. So this is mu is less than 74. You can also think of it this way. This one on the left is the left test, and this one on the right is the right tail test. So we're going to use the left test because it's less than, and I go down to calculate, And the information is given there. It gives me this t number, this p-value, and then the x-bar and the sample standard deviation. So I wrote these numbers down, and so let's finish the problem. So my x-bar to 2 decimal places, my x-bar is 71.4, and that's it. That's the all the decimal places I have. So let's put in a 0 there, so that way it's 2 decimal places. And then my sample standard deviation is 20.65 is my sample standard deviation. I rounded up to 6.5. Okay, so then what is the level of significance? Well, the level of significance is 10%, so 0.10 or 0.1. So this is my, it actually says level of significance, right? But remember, sometimes we refer to this as alpha. So the alpha is 10%, so 10% level of significance. And then state the null and alternative hypothesis. So once again, remember this. In statistics, for a hypothesis test, the null hypothesis must always include equality. There is no exception to that statement. It must include equality. So it cannot be the first one and it cannot be the last one because they have non-equalities. Equality, equality, equality. The null hypothesis must include equality. So it's one of these three. And then we're looking for less than 74, so the left tail. So this would be the equality and null hypothesis, and then less than 74 is what we need. And sometimes that gets referred to as a left-tailed test. This would be not equal, so two-tailed, and this would be greater than, so a right-tailed test. But it's less than, so we're going to use less than. All right, so part B, what sampling distribution will we use? Well, we already said we're going to use the student's t, so that's one of these two, and has a normal distribution, approximately normal, and the sigma is known is not correct. The sigma is unknown, right? So sigma is unknown. Student's t, we assume it has a normal distribution, and sigma is unknown. And what's the value of the sample test statistic? Well, that was the t on our calculator. So this is the sample test statistics, the t. And so I wrote that number down to 3 decimal places is negative 0.0563. And I made a mistake here. Let me fix that. 0.563. So my test statistic is negative 0.563. And then part C says find the p-value round to 4 decimal places. So rounded to 4 decimal places, I think is 0.299 or 2900. And so if I round this p-value to 4 decimal places, this would round to up to 10, which makes this round up to 10, which makes this round up to 9. So 29 and then 00 is how I'm going to answer that to 4 decimal places. Then I want to sketch the graph. So remember, I'm looking for a less than, so a left tail. And so it's either going to be this one or this one. Those are the 2 left tails. And my sample test statistic was this negative 0.563. So that has to be this one, right? That has to be the one where the area is to the left of negative 0.5. So that's to the left. It wouldn't be this one because that would be positive. So we want the one that's the negative, so over here to the left. So then based on your answers to part A and C, would you reject or fail to reject the null hypothesis? Are the data significant, statistically significant at the level of alpha? So what I'm trying to do then is compare my p-value to my level of significance. So the question I'm always asking then is my p-value less than or bigger than my alpha? And in this case, my p-value is bigger than alpha. And in statistics, we fail to reject big things. So we reject small things and we fail to reject big things. In this case, 0.29 is bigger than 0.1, so we fail to reject. So I go down and say we're going to fail to reject, so it's one of these two. So at the 0.10 level, we fail to reject one of these two. And if we fail to reject, then the truth is we really don't know anything. So it's definitely not statistically significant. So I click here. And so I agree with this answer. At the alpha equal 0.10 level, we fail to reject the null hypothesis. And how I would actually answer this question as, and we know nothing. So what the textbook author is trying to emphasize is saying that the data is not statistically significant, but the truth of it is we really don't know whether the data is statistically significant or not. The best we can say is we failed to reject. So that's splitting hairs a little bit, but the answer is definitely not this one, where it is statistically significant. So I suppose you could make the argument that it's not statistically significant. But the real truth of it is we don't know if it's statistically significant or not. So we fail to reject, and then I answer the not statistically significant because that's the one they want us to answer. All right, so interpret my conclusion. So there is insufficient evidence at the 0.10 level to conclude that the population mean is less than 74 years. So there's insufficient evidence. Okay, so let's submit our answers and see how we did. And it looks like for all of our questions, we got the green check mark, and it looks like we did it right. Okay, if you have any questions, please let me know.